Yeah, morning to everyone. So today we are going to study about Carnot cycle. Carnot cycle. It was first means it was studied and it was what about the Carnot cycle exactly works was suggested by French engineer Sadi Carnot in 1824, and he basically worked on the reversible cycle. So it is that's why it is known as Carnot cycle. So Carnot cycle basically works with a reversible cycle. And this figure, if you just see here, some fluid is entering here. Any fluid, like suppose any fluid, it is used in refrigerators or in Carnot cycles. Carnot cycles is nothing but Carnot cycles or heat engines or heat pumps. For all those things, we will be having two reservoirs. One is heat resource, that is heat source T1, and heat, so that is another is T2. So source is nothing but which is having high temperature, and absorption of heat is take place here. So it means it absorbs heat and releases heat from this source. And sink means it is the low temperature where that is T2. So here, when let us imagine that these are the two heat sources. One is the source and the sink, and we are having one engine, and the engine is having one piston here. This is a cylindrical one. It is having a piston. Mm, So what is happening here? Here, to do some work, what happens? Whatever this high temperature source is there, it tries to introduce the fluid. So, So here it's nothing but when heat is the high temperature heat is trying to flow into this cylinder. Why? Because see, the cylinder has the piston. This whatever this piston is there, it has to do some work. So to do some work, what is happening? Some amount of high temperature is introduced into the work, so the piston starts doing some work. And what happens when a temperature is introduced here? Whatever this piston is there, it tries to move forward. It tries to expand. So what happens? The volume also expands, and the piston tries to do some work when some amount of heat is introduced in this piston. And with this, the piston tries to do some work, and when during the when the work is done, what happens? Whatever this uh, piston is there, it tries to do some work, and some energy is liberated. Okay, and in the same way, so this is means here two things are taking place, doing some work. How we can know? Suppose piston is there, when it is compression is taking place or expansion is taking place. Two things are with the two things we can identify that the work is done. So how this work is done? The expansion of this piston is taking place by introduce of high temperature. The work is done, and when the compression of piston is taking place, the piston moves downward. Then what happens? Whatever the heat is there, that the heat tries to come out, and that is really sent to the sink. Okay, so this is the working performance of this Carnot cycle. Whatever the Carnot cycle is there, what happened? Some amount of high temperature is induced. When a high temperature is introduced, what happens? The expansion is will be taking place, and when the temperature is lowest down, when the temperature lowest down, that is nothing but the compression of the cycle is taking place. So these things you need to remember. So these are the Carnot engine cycle, and this is the Carnot heat pump cycle. So when you just see here, two things are taking place. One is in this, first of all, this graphs represents the pressure versus volume, because when you just see this also, what happens when the temperature is increasing? It's nothing but the expansion is taking place. How this expansion is taking place? Those with some pressure, putting some pressure into this engine, that the piston tries to move forward. So here, when the piston is trying to move forward from here to here, what happens? There is a change in the volume takes place. So that's why you are plotting the graphs between pressure and volume. And during this process, we can see that two things will be happening. One is isothermal and adiabatic. Isothermal means the temperature will be constant, and adiabatic means heat will be zero. Okay. So here, so when you just move here, when you just see the graph, 1, 2, 3, 4. Okay, please try to put this graph on your paper, because next we will understand the step by step this diagram of these things. I will explain how this graph is occurring and what happens during this graph. We finished drawing this graphs. I'll go to the next slide. And try to remember, just try to find out the difference between this engine and the heat pump. What you are saying, isothermal expansion or compression here, you can see from temperature point 1, our point, see, the assumptions made for describing the working of Carnot engines are as follows. What are the assumptions? One is the piston moving in a cylinder does not develop any friction during motion. See, these are all the assumptions which we are putting when you are going to study about the Carnot engine. Okay. The other is the walls of the piston and cylinder are considered as a perfect insulator of heat. Insulator means what? Then our Q will be equal to 0. The cylinder head is arranged that it can be perfect in conductor or perfect insulator. Okay. So whatever the cylindrical arrangement is there, either the heat can pass through the cylinder, or the heat cannot be passed through, whether Q is equal to 0 or Q is not equal to 0. Next, the transfer of heat does not affect the temperature of source or sink. Next, working medium is a perfect gas and has constant specific heat. The compression and expansion are reversible. So these are the assumptions made to study or to know about the working of the Carnot engine. Okay. See, assumptions, why you are putting assumptions? Because, see, like suppose if I take a balloon, okay, if I say that if I study, if I do assumption that in the air of the balloon is an ideal gas, then I can start studying about this. If I think that my assumption is a real, then it is not possible, because in a real gas what happens, so many parameters keeps on changing. So that's why we put the assumptions. Why we put the assumptions in the content? We start fixing some points, and fixing some points, we start studying about that particular criteria, particular any point. Okay. So there are 4 stages of Carnot cycle. Please try to just open that diagram. I'll just explain that diagram. So process 1 to 2. Process 1 to 2, that is this graph. Process 1 to 2, that is nothing but stage 1, where hot energy supplied is applied. See here, hot energy source is applied here. Means what? Here the energy, whatever the it is there, the heat is coming from the source. Whatever is there, let us imagine that here some source is there and here some sink is there. So what is happening? Whatever this source temperature is there, it is trying to enter into the engine. Imagine that this is the engine, our engine. Okay. So hot energy source is applied. Heat Q1 is taken in, the expands isothermally. Means what? When amount of heat is introduced into the engine, parallelly what happens? The expansion takes place. The expansion means whilst the fluid expands isothermally. What happens when some amount of hot energy is, or hot temperature is introduced into the process? What happens? The heat, whatever the heat is there, it is trying to enter into the system. And during that process, or at a time, what happens that whatever this piston is there, the piston tries to expand isothermally. Isothermally means the temperature being constant. Okay. and reversibly at constant high temperature T1, because we are getting a temperature from source, so it is T1. Okay. Next, go out with the process 2-3. This one 2-3. So here the first 1-2 is nothing but what? We are getting some source, whatever this source, high temperature is there, it is trying to introduce or trying to enter into the system. So what happens when it's trying to enter into the system, an amount of Q is being entered. So when the Q is entered, whatever the piston is there, the piston tries to expand. The piston, what happens? The piston tries to expand when some amount of heat is formed. So, and that amount of heat is formed at constant temperature. At constant temperature. And next, 2-3. So, what happens to the 2-3? The cylinder becomes a perfect insulator so that no heat flow takes place. So, here what happens? The cylindrical whatever is there, it is becomes an insulator. Since these are all the assumptions what we are talking about the Carnot cycle. So what happens when we say that it is a perfect insulator? So what do you mean by perfect insulator? So no heat of will come into the system or go out of the system. Okay. So then what happens? There is no change in the heat flow also. Whatever the heat formed, it will be retained in the system like that only. So the fluid expands adiabatically and reversibly parallelly with the temperature falls from T1 to T2. So what happens? Suppose if you take a cup of